All right, well, you can see that I'm back, and since I'm wearing the same thing, it's minutes after I finished my first round of discussion of groundwater economics. Actually, I'm going to throw this graph back up here one more time. Hey, that's the stuff you struggle with the most, so maybe there's no such thing as overexposure to economic models, especially in the form of a two-dimensional graph. One of the things that I should have made a bigger deal about, perhaps to connect to what might be a familiar term to you that maybe you've heard but you weren't sure exactly what it meant, is tragedy of the commons. See, that's what happens when the demand increases from D0 to D1 and nothing is done. That's called tragedy of the commons, because up to D0 and a little teensy-weensy past D, up to where these lines start to separate, everybody doing what they want is just fine, perfectly efficient. Wouldn't be efficient, would be inefficient to enumerate, to quantify pumping rights and find out some way to have them be tradable, because there's no need. Tradable means that what you need is for when one person pumps more, somebody else pumps less. Just a little past D0, that's not the case. But once demand shifts much past D0, it is the case. And if nothing is done, then what happens is that you have a common property resource situation, and when the resource itself becomes scarce, okay, for example, wildlife, fish, communal grazing pasture, that's often where the tragedy of the commons terms comes up. People are thinking, this pasture belongs to the whole village. It's my turn to graze my critters. If my critters don't take all the grass that's there, it won't make any difference because the next person's turn, they will, okay? The tragedy of the commons. What everybody owns is treated by each individual as if nobody owns it. It's often called the race to ruin, because you see, without the actual property rights and access to units of the resource, it's treated as if nobody owns it, and I better capture it or somebody else will. So it begets irrational behavior. Everybody knows that it's irrational, but until the property rights are changed, everybody does it anyway. All right, so enough with this graph. The rest of our discussion of groundwater will surround our discussion of how to actually put it in place. And again, it'll sound familiar. It'll sound just like, well, at least a lot like what we discussed for water, and it'll sound a lot like what we talk about in a little bit, perhaps still today. You can tell what day, whether it's the same day based on what I'm wearing. We talk about fisheries. All right, so in the case, just to be specific rather than abstract in general, what could you do here in the San Antonio area to pull this off? We haven't had the prior appropriation doctrine that we've discussed with water. So what you could do is to have the J17 wells. There's a very specific item. Google that if you want to, because that's a particular well that if you watch the news carefully, you often hear during the weather segment the reporter cite the J17 well level. That's sort of a barometer of how full our Edwards Aquifer is, how close to the top it is. Because any number they've ever reported, it's about 70, 80, 90% full. And when they report a number around 700, it's brimming full. Every springs there is, not just the two famous ones at Comal and San Marcos, are just squirting water all over the place. But it's been down in the 610s, 612s before, even in the 1950s, before we had anywhere near the population that we have now, because there was a long drought in 1956 and prior to that. And so Comal Springs went dry and San Marcos was getting close. Now we have a lot more people, so it wouldn't take nearly the drought that we had in the 50s to have that same situation if we continue, or if we were to continue to manage the Edwards Aquifer as a common property resource. We ended that in the 1980s, although we could have ended it in a way that was much more conducive to economic efficiency. But we did quantify pumping rights beyond certain small quantities for domestic and home use. So, for example, if you just have a house out in the hill country, and you just want to pump for domestic use, you don't need to buy pumping rights for somebody else. That small quantity is literally a drop in the bucket. But if you want to irrigate a large farm with a standard 2 acre-feet per acre, in other words, enough water to cover your ranch 2 feet deep in water, of course you don't pour it on all at the same time, that much water, yeah, you're going to need a pumping right, and it's going to have to come out of the total allocated. Okay, so how would we get to a situation like that that's more efficient than the one that we have now? We could use the J17 well as a basis to prioritize different levels of pumping interruptibility. That's kind of a bizarre term. Different levels of pumping interruptibility. All right. What this means is we have to prioritize pumping rights, right? It may be a groundwater resource, but ours here in San Antonio is kind of like an underground river, right? So what we have to do is plan for times when the water table is lower, and thus we probably won't be allowed under the Endangered Species Act to pump quite as much, because we can't endanger the spring flow where the endangered species are. And so because of that, some water rights are going to be exercisable. It's going to yield water in times when the water table is up, and not be able to yield water in times when the J17 well level, the water, that's sort of the indicator of where the water level is, when that water level is lower. All right, and I think I've gone over this basic notion before. We could have Class A rights, Class B rights, Class C rights. The difference between each one of them would be based on the J17 well level. So, for example, it could say that even if the J17 well hits an all-time low at 610, the Class A rights are golden. Okay, if you own one, you hold one of those, you can pump that amount of water. Okay, but then probably only the Class A rights. Okay, Class B rights, probably not interruptible very often, but if the well level drops below, say, 640, 630, those would be, if you have one of those, sorry, you can't use that to pump anything, and so on. Class C rights, 640, 650, 660 for the J17 well. If it's above that, pump with your Class C rights. If it's below that, sorry, you can't. Okay, so you throw that into a marketplace. It's divisible, easily transferable. We get an efficient allocation of water, and we keep those MMBs equal. What would happen under a circumstance like that with Class A rights, Class B, Class C, that had different levels of interruptibility? Most water users would buy a mix, right? Because the marginal benefit line for any water user starts high and goes low. That means that some water uses are extremely valuable, right? And for those, you buy the Class A water rights. You pay the money to keep those going. And then as you go down your individual marginal benefit line, additional water uses are valuable, but not invaluable. They may not be valuable enough to justify the market price of a Class A water right, but they may be valuable enough to justify a Class B water right and a Class C water right, the same thing. Okay, so that would be the basis for having an efficient allocation here. Now, what would you do given that you politically you can't pull off an auction? Now, again, that would be the most efficient thing to do, but not politically correct. So you'd probably have to do the best you can to collect records of pumping and issue those initial water rights. Class A, B, C probably have the Class C water rights further lower. Who knows how many levels that they would create for those correlative rights. But in all likelihood, the water users would come out of the woodwork with all kinds of asserted proof of immense need for pumping rights, and the sum total of all of those would probably be way more than the level that you'd want to constrain your water rights to. Doggone it, I am going to pull this graph out again. Here it is. Okay, so for example, if you wanted to constrain to Q0 star, okay, and all the pumping rights that somebody claimed were historical, right, exercised in the past, plus those that were implied but not used, the correlated rights, those would probably add up to way more than, and referring here to Q0 star, probably way more than that. So we've discussed this before, but just to be specific here, what would you do? You could either phase down the rights, take some, tax them upon transfers. In other words, if you buy or sell, you have to pay for more than you actually get access to use. The difference is taken out of circulation to phase down the total number of rights that are in existence to eventually a level that's sustainable long term. You could have a pumping fee, and then the revenue from the pumping fee would go to financing the authorities purchasing and then retiring water rights. And as always, just as we had back with the emission allowance, there's no stopping a private group from fundraising, finding some money and taking some of those water rights and just refusing to access them, believing perhaps that the authorities had over-allocated water. Why would they care to do that? Well, if the authorities over-allocate water, that affects stream flow, river flow, right? Here in San Antonio, our aquifer is the starting point of the San Marcos and Comal rivers, which eventually dump into the Guadalupe River, which eventually dumps into the coast. And then less water at the coast has environmental impacts. So it's not entirely far-fetched to think of some environmental group or groups saying, and we think the authorities have issued a few too many water rights. Why don't we just buy some, take them out of circulation, and then keep them? You never know. Maybe we're wrong and we can sell them back and get some money back out of it. Maybe it's an investment, right? Maybe we don't want to tear them up and throw them away, but at least for now we'll take them out of circulation and see from their perspective if the marginal benefits of having purchased them, thus increased stream flow, is equal to the marginal cost of the environmental group. See, more economics. Marginal cost of the environmental group of diverting funds from other uses that they had. All right, so let's see what's left here to discuss. All right, so again, we need to have easy transfers at market prices, because otherwise, water rights holders will refuse to relinquish water rights temporarily, especially thinking that they can get them back. It's hard to consummate a trade, right? If it goes through all kinds of hassle and uncertainty about whether it'll be approved, then the water rights holders, those will probably just say, I just can't take a chance on the ability to get this water back when and if I need it. Okay, so we need a history of easy transfers of water so that buyers can say, look, there's a going rate, or at least if the market is thin, an approximate going rate that I think I can buy into. And also, there it is, a signal of what I can sell for. If not permanently, in the short run, let go of it for a couple of years when I don't need it or have an important enough use for it. And if that should change later, to be able to go back and buy into it. Oh, also, no beneficial use test. Again, think of the political process of all days. By the way, today that I'm making this video, it's the election day, November 8, 2016. Think about the political process and how that works. Who could possibly be against, say, the no injury doctrine or beneficial use of water, beneficial use doctrine? But, the politicals put nice labels on dumb things, and from at least from an efficiency perspective, the beneficial use doctrine, the no injury doctrine, the beneficial use doctrine, those are all dumb things. Again, I'm telling you, from an efficiency perspective, I can prove that mathematically, or at least I can find a proof of it mathematically to show you. Now, whether it's a dumb thing to do once you consider other things, intelligent people will disagree. They must disagree because these doctrines are in law in some places, and maybe there weren't enough economists in the room to point out the inefficiency. I don't know. Maybe they were just voted down. Like, yeah, we hear you economists. Sorry, just don't agree. And we want to make sure that water was put to a beneficial use, maybe because they recognized that it was not going to ever become easy to make transfers, so that those who had the water use rights would definitely have to put them to some beneficial use or have to give them up to make them available for somebody else to have them, to take them, basically. See, and that's why the beneficial use doctrine is inefficient, because it tells water rights holders, water use rights, water ownership rights, that they better put that water to some purported use, maybe not to any actual use, but turn the tap, make the meter spin that says the water went out. Okay, so how can the authorities tell it wasn't used for anything and just flowed down the tap and down the canal and back into the river, or evaporated? That they probably can't tell. But at least the meter will register that the total amount of water rights were actually taken and hopefully put to some use, because running a pump isn't typically free. Now, there are some water users that are over in what are called the artesian parts of groundwater, which means if you poke a hole, it comes squirting out under its own power, and then there isn't any pumping cost. And there's just a well capping cost that says maybe we don't want it to come squirting out that fast, and we need to regulate the speed at which it comes squirting out. But anyway, at that point, that's pretty cheap. I mentioned once before about the Ronnie Puchek catfish farm. That was in business for a while over an artesian part of the Edwards Aquifer. In other words, Mr. Puchek poked a hole in the ground, water came squirting out under its own power. He said, wow, under Texas law, all this water is mine. What can I do with it? Oh, catfish farm. That takes an awful lot of water, but here it is, free to me, coming out of the ground. Yeah, it may be expensive to others because it draws the water table down, but maybe they'll buy me out. And that's ultimately what they did, because they didn't, that was drawing the water table down. And so they had to, he did nothing wrong under the law at the time. In fact, what he did do is provided an important economics lesson that may have helped bring about the quantification of pumping rights, even if not efficiently. And by the way, what do I mean by that? The quantification of pumping rights, even if not efficiently. Well, all water trades in a lot of places, in California, in a lot of places, but also here in Central Texas, have to go through what's called a water bank. In other words, you can, if you think that it might be worth your while as a water rights holder to sell or temporarily lease some of your water, the only person or entity that you can sell or lease the water to is this water bank managed in this area by the Edwards Aquifer Authority. And if you want to buy some water rights, you can't go into a market and buy it from somebody else using it. You have to go to that water bank and see if the Edwards Aquifer Authority has some water rights that they purchased from somebody to sell to you. So that doesn't provide anywhere near an efficient market. So why did the powers that be do that? Well, they wanted to manage the location and or the nature of water rights that were taken out of service because they wanted to prevent pecuniary externalities. Pecuniary externalities are not the kind that create inefficiency. Those are not the kind that you need a policy response to. Pecuniary externalities is just the market working to reallocate resources from low-value uses to high-value uses. Nevertheless, as a result of doing that, there are losers, right? The people doing business with the low-value water users that then give up their water to higher-value users are going to say, no. If we have anything to say about this, we don't want those low-value water users to be able to trade there because they're not going to do as much business with us as a result. Okay, for example, the farm supply store that says, no, that irrigation water may not be a very high value use, but if that stops, our business goes out of business, and no, we don't want to do that. If we have the political clout, we'll just do like I just did at the polling place a little while ago. We'll just go, boop, right? How hard was that? Okay, not hard at all. And very expensive to somebody else, but beneficial to those going, boop, vote against, nope, stop. Keep those restrictions. No injury doctrine. Don't hurt me by allowing the owner of the water. Imagine that. They're voting to prevent the owner of something from being able to sell it to somebody who values it more than they do because of the pecuniary externality of them losing business if they trade the water to somebody. So what does this water bank do in different places, including here in Central Texas? What it does is it allows the farmers to only sell some of their water rights, and then only in this area half is the max. The low-value water uses are known to be the farming uses of them. They can't sell all their water rights. At least half have to stay on their farm, presumably doing some farming, and out of the other half that is available potentially to sell, it's only available if the irrigators make it available through conservation. In other words, find a way to keep growing crops on their land with less water, right? That eliminates those pecuniary externalities. Now, fortunately, in the water business or in the water industry, there's so much water in low-value uses in agriculture, and the demand line in the higher value uses is so steep that it only takes a relatively small amount of water moving from the low-value uses in agriculture to the high-value uses in municipal and industrial and commercial to make a huge difference, right? So far that's true. Now with increased population growth, that may change. Let me give you a quick example from some numbers that I know in California. In California, 80% of the water rights, I think that's overall groundwater and surface water. It might just be surface water. Anyway, you get the idea. 80% of the water is in agriculture. All right, so 20% in the urban uses. All right, so if the agriculture users give up 10 percentage points of their water, go from 80 to 70, something that they could relatively easily do given how some of the water is used, just flood irrigation. Go to some more efficient irrigation, well, more expensive though. So depending on what they can get for the water, that may make sense to them, it may not. But anyway, all right. So if through conservation they can get by on 70% of the water rather than 80%, that adds 50% from 20% to 30% of the water and other uses, which massively lowers the price needed to ration out what's available, and probably massively delays, or maybe, at least for our lifetimes, depending on future population growth, maybe permanently puts off having to build massive water projects to make up for the fact that water is stuck in agriculture. Right? There's been a lot of that going on. People growing low-value crops with flood irrigation, $20, $30 worth of an acre foot of value for the water. And because it's hard to transfer the water, either groundwater or surface water, into higher value uses, the cities are having to build water projects, piping the water over mountain ranges, piping water over mountain ranges and long distances to meet the needs of their growth. It's an amazing thing. So anyway, we need to have easy transfers at market prices to make sure that the market runs smoothly, so that the water users that are willing or thinking about selling will be willing to do so, knowing that if their demand for water would increase in the future, that they can get the water back, and in the meantime, they don't have a high value use for it now. They can make some money in the process. Okay, so two other points to make before we call it a wrap, as they say in Hollywood, for this video on the groundwater issue. One is that with aquifers much different than ours, and with ours, it's possible that we need to add the complexity of different trading ratios between different users on different parts of the aquifer. The example in this area would be the westernmost part of the aquifer is at a different elevation. In other words, the water table is higher there than it is on the Bexar County, Medina County, not all of Medina County, most of it, part of the aquifer, which means that if we have water rights trades from here to here, that'll draw the water table down here, perhaps unacceptably. It won't leave it constant, right? Because more pumping here, it doesn't fully, less pumping here doesn't fully offset more pumping down here at the lower Bexar Medina, lower part of the aquifer. In other kinds of aquifers where water is being sucked out of porous soil, the need for different trading ratios is because the water travels slowly through the permeable layer, and so pumping more here versus here can actually draw the water table down, which affects other users in the vicinity of that pipe, in the vicinity of the pump here, that's acquired additional water rights. Sadly, that's a complexity that we probably need to accept. So we need to turn the hydrologist loose to determine the rate at which taking less water out of one part of an aquifer creates more water in another part of the aquifer, and to what rate over time the water moves from the one place that's taking less to the other place where that's taking more. Okay? So we economists, in our schemes for making things efficient, have to live with the data, have to function with the data that we get from physical scientists like hydrologists and others. Okay, and the last aspect of a market for water rights, groundwater rights in this area of Texas especially, is that if you have marketable water rights, you should be willing to grant them, increase the total number available, if somebody manages to increase the recharge into the aquifer, right? So the amount of initial water rights, here's my graph again. Let's say the amount of initial water rights is right there where my middle finger is, Q star 0. Okay, how might that be increased over time? Well, let's say some farmer out in the hill country, a rancher, puts a dam across a sinkhole. Okay, so now when it rains big time, the water is going to stop over that sinkhole instead of racing across it in a flood, and it'll sink down to the sinkhole. If we can figure out a way, and maybe it already exists, to document how much additional recharge those projects create, well, then we can award and incentivize those kinds of projects by saying, oh, you rancher out there on that property, by putting those dams out there, that'll increase recharge by 100 acre-feet. And each acre-foot sells for, say, $300. So here you go. Okay, so here's your 300 acre-feet of water rights that you can use yourself or put into the market. Let's see, and 300 times 100, wow, that's $30,000. That might be more than enough to stick a bunch of rocks across the downhill side of a sinkhole. Okay, so that's another reason to have markets in water rights, tradable water rights, because that incentivizes folks on the supply side. All right, that's about all I've got to say today on water rights. Looking at the clock, I think we're going to have to talk about fisheries at another time. But let's get after our discussion today on groundwater rights. Bye-bye. So the property rights were changed. Everybody does it anyway. All right, so enough with this graph. The rest of our discussion of groundwater will surround our discussion of how to actually put it in place. And again, it'll sound familiar. It'll sound just like, well, at least a lot like what we discussed for water, and it'll sound a lot like what we talk about in a little bit, perhaps still today. You know, you can tell what day, whether it's the same day based on what I'm wearing. We talk about fisheries. All right, so all right, well, you can see that I'm back, and since I'm wearing the same thing, it's minutes after I finished my first round of discussion of groundwater economics. Actually, I'm going to throw this graph back up here one more time. Hey, you know, that's the stuff you struggle with the most, so maybe there's no such thing as overexposure to economic models, especially in the form of a two-dimensional graph. One of the things that I should have made a bigger deal about, perhaps to connect to what might be a familiar term to you that maybe you've heard but you weren't sure exactly what it meant, is tragedy of the commons. See, that's what happens when the demand increases from D0 to D1 and nothing is done. That's called tragedy of the commons, because up to D0 and a little teensy-weensy past D up to where these lines start to separate, everybody doing what they want is just fine, perfectly efficient. Wouldn't be efficient, would be inefficient to enumerate, to quantify pumping rights and find out some way to have people are thinking, you know, this pasture belongs to the whole village. It's my turn to graze my critters. If my critters don't take all the grass that's there, it won't make any difference because the next person's turn, they will. Okay? The tragedy of the commons. What everybody owns is treated by each individual as if nobody owns it. It's often called the race to ruin, because you see, without the actual property rights and access to units of the resource, it's treated as if nobody owns it, and I better capture it or somebody else will. So it begets irrational behavior. Everybody knows that it's irrational, but it's going to be tradable because there's no need. Tradable means that what you need is for when one person pumps more, somebody else pumps less. Just a little past D0, that's not the case. But once demand shifts much past D0, it is the case. And if nothing is done, then what happens is that you have a common property resource situation, and when the resource itself becomes scarce, okay, for example, wildlife, fish, communal grazing pasture, that's often where the tragedy of the commons terms comes up.